Huh? Okay, students, good morning. Okay, fine. As in the previous classes, already you know what is the isomerism in organic compound with their naming, with polar, non-polar character, with dipole moment. Today, we will discuss another topic, that is inductive effect. Inductive effect. So today's topic is inductive effect. Before going to the effect, first tell me what is name of this compound, that is CH3, CH2, CH2 and CH2Br. What is name of this compound? There are 4 carbons, 1, 2, 3, 4 and bromine. So it is a halogen group. So name of this compound will be, you can say it is bromobutane. Yes or no? It is bromobutane. Bromobutane. Bromine and 1, 2, 3, 4 carbon, bromobutane. Now you know that carbon is less electronegative and fluorine, chlorine, bromine, iodine, all these are highly electronegative. Highly electronegative. Then what happened? In general, NaCl, when it breaks, it forms Na plus and Cl minus. So we can say directly Na plus and Cl minus. This is for ionic bond by loss or gain of electron. But in this organic compound, there is no any loss or gain of electron. Then what happened? There is sharing of electron. Sharing of electron means it is covalent bond. Covalent bond means you know polar and non-polar bonds. And this type of bond is polar bond, as there is a difference between the electronegative character. So when this bond occurs in polar nature, it cannot break down into plus or minus ion directly. Then what happened? This portion I am writing separately. C bond bromine, that is carbon bond with bromine. In bromine there are 7 electrons, and in carbon there is bond formation. Okay, now we cannot break this bond. You cannot break this bond. How? Now write another simple example, HBr. HBr. To understand clearly, write a simple example. HBr, that is hydrogen and bromine. This is which bond? Polar covalent bond. Polar covalent bond. Like NaCl, we cannot break this bond because there is sharing of electron. Now what happened? It is electropositive, it is electronegative, and there are more electrons. So this electron cloud shifts towards bromine from hydrogen. Understand carefully. This bond will not break, but what happened? Electron clouds shifts from hydrogen to bromine. So what you learn? What you learn from this? What you learn from this? Electron cloud or electron density will shift from less electronegative element towards more electronegative elements. If you compare hydrogen, it is okay, but if you compare carbon and bromine, carbon also less electronegative element, and fluorine, chlorine, bromine, these are also what? High electronegative element. So electron cloud shifts from less electronegative to high electronegative element. This is called inductive effect. So what is definition of inductive effect? Definition of inductive effect is the shifting of electron cloud from less electronegative, I am writing in short form, less electronegative element to more one or more electronegative element. The shifting of electron cloud from less electronegative element to more electronegative element. Now come to the organic compound. What I have written the first, that is CCBr. Understand clearly? This is bromobutane. Now in this compound, carbon is less electronegative, bromine is high electronegative, so electron cloud shift from carbon to bromine. Then what happened? There is a partial negative charge appear in the bromine, partial negative, and partial positive charge in the carbon. Look this point carefully. After shifting of electron cloud, this is your inductive effect, this is your inductive effect. Now after shifting of electron clouds from less electronegative to more electronegative, that is from carbon to bromine, there is a partial, not total positive or negative charge. When we separate sodium and chloride, that is NaCl, Na totally becomes positive and Cl totally becomes negative. But in this condition, there is a partial charge, because only shifting of electron cloud. So this carbon becomes partial positive, that is delta positive, and it becomes delta negative. This effect is called inductive effect. Understand carefully? Now I have taken one example for bromine. Then what happened with other atoms like fluorine, chlorine, you know? What happened? Fluorine, chlorine, bromine, iodine. These are halogens. And this is most electronegative, then chlorine, then bromine. When electronegative increase in electronegativity, increase in the inductive effect. That means when electronegativity will increase, inductive effect also increase. That means fluorine, chlorine, bromine, then iodine. Understand? Then mark another thing. The fluorine, chlorine, bromine, iodine, these are highly electronegative elements. In their outermost orbit, there are how many electrons? 7 electrons. So they want to receive or gain 1 electron to become stable configuration. Understand carefully? That's why after receiving 1 electron, it will become positive or negative. Obviously negative, yes or no? It will become obviously negative since the halogens receive electron and becomes negative. These are called negative inductive effect. A negative inductive effect. Okay. Now inductive effect is again two types. One is positive inductive and another is negative inductive. So what is positive inductive effect? I effect. Short form is called, we have to write I effect. Positive inductive effect and negative inductive effect. What will give positive inductive effect? All the halogens including fluorine, chlorine, bromine gives negative inductive effect. That is, all halogens functional group, okay, and positive alkyl group. Alkyl group gives positive inductive effect and all halogens or functional group give negative inductive effect. Okay. Now, say me one question for you, that is CH3 Br, CH3 Cl, CH3 F and CH3 I. That means bromomethane, chloromethane, fluoromethane, iodomethane. From these four, which have least inductive effect? Now my question to you, find which have least inductive effect. Find which have least inductive effect. Write your copy. In your copy, find which have least inductive effect. There is a point in your note. Which have least inductive effect? Which will have highest inductive effect? Okay. If you don't imagine about least inductive effect, then find which will have more inductive effect. First imagine which will have in the increasing order of electronegativity. There are four atoms: bromine, chlorine, fluorine, iodine. The elements in the increasing order of their electronegativity, and conclude that which have least, more and least. We have done. Look me carefully. Fluorine, then chlorine, then bromine, then iodine. Iodine is least electronegative. That means more electronegative is fluorine and least electronegative is iodine. Then obviously, which have least inductive effect? Your answer will be this one, CH3. Understand? Any doubt? Now, important point. CH3 again, CH2, CH2 and Cl, suppose Cl. Now, it has partial negative charge, it has partial positive charge, it has very less partial positive charge, it has very less partial positive charge, or negligible. That means it is concluded that when carbon chain increase, your inductive effect gradually decrease. When your number of carbon chain increase, your inductive effect also gradually decrease. Next one important thing is that acidic character. acidic character. Acidic character increase. Listen, acidic character increase with increase in inductive effect. Inductive effect. If inductive effect increase, then acidic character also increase. That means if we consider previous one, then fluoro, that is fluoro molecule, fluorine, will more acidic than chloro or bromo. Okay. Now, last topic is that CH3, CH2 and suppose Cl. According to inductive effect, this will becomes partially negative and this will becomes partially positive. Yes or no? Now, electron cloud shift in this way. Electron cloud shift in this way. Now separate this one. Separate this one and write here. What happened? C positive. Yes or no? Again, 3 bond. This is separate and Cl minus. That is partially negative. Yes or no? Now, does this carbon atom have a positive charge? Yes or no? With carbon, positive charge. This type of molecule or atom or ion is called carbocation. This is called carbocation. What? Carbocation. So what is carbocation? Right? Carbocation is the ion with carbon having positive charge and 6 electrons. Listen carefully. There are 6 electrons. 1, 2, 3, 4, 5 and 6. There are only 6 electrons. 1, 2, 3, 4, 5, 6. Due to positive charge, electron transfer to this side. So there are 6 electrons. That means carbocation means carbon atom with positive charge and 6 electrons. How many electrons? 6 electrons. You know cation. Meaning of cation is negative charge. Sorry, meaning of cation is positive charge. So there is a positive charge. That means cation, but due to presence of carbon, it is carbocation. Understand? Last point, remember carefully, tertiary carbocation, this is carbocation. Tertiary carbocation is more stable than tertiary than primary. Why? This is tertiary carbocation plus this is more stable, then this is H more stable, then CH2, this is primary, this is secondary and this is tertiary. Primary, secondary, tertiary. Tertiary carbocation is most stable. Tertiary carbocation is most stable due to, listen carefully, this positive charge is shared by 3 sides, 1, 2, 3. Okay. Due to sharing of 3 sides, it is more stable, then secondary is low stable and primary carbocation is least stable. So from today topic you learn two important topics, that is inductive effect. That means inductive effect means transfer of electron from less electronegative to higher electronegative element, that is transfer of electron cloud from less electronegative to more electronegative element, inductive effect. All halogens, all functional groups show negative inductive effect. Alkyl groups, that is R, it show positive inductive effect. And one is carbocation. What is carbocation? This is a carbocation. Example CH3 CH2 CH2 plus. This is carbocation. In carbocation, tertiary carbocation is most stable. So our today topic inductive effect and carbocation. In the next class we will discuss how the carbocation and inductive effect are helpful to know or to understand the acidic strength in organic compound, that is in simple organic compound or aromatic, that is benzene, phenol. Understand? Okay. Thank you.